There is a different way to start solving method of group averages when nonlinear curves are involved. Learn more about it here in Numerical Solutions to CE Problems. Unlike the solution of best fit line using method of grouped averages, a preliminary step of transforming the equation of the curve into the general linear form of y is equal to ax plus b is required. In such transformation, you are to use a coordinate from the dataset assuming that the point is where the curve lies. After identifying the linear general form, one can proceed with the method. Let's work with the best fit curve with the format y is equal to ax squared plus bx plus c to the same data we worked on with the best fit line in the previous video. In order for us to transform the equation to y is equal to ax plus b, choose a point from the dataset and assume that the curve will be passing through this point. So plug in the coordinates into the equation and have the outcome as equation 2. Subtract this equation from the former equation and we arrive at y less 0.1002 is equal to a times the quantity x squared minus 0.1 squared plus b times the quantity x minus 0.1. The coefficient of a, which is x squared minus 0.1 squared, is also the difference of two squares, and we can expand this as x plus 0.1 times x minus 0.1. And by this point, we can see a similar term on both ends. If we extract this term to simplify the right side of the equation, we can have y minus 0.1002 is equal to x minus 0.1 times the quantity a times x plus 0.1 plus b. If we transpose this term to the left side to the equation, we can then end up with y minus 0.1002 all over x minus 0.1 is equal to a times the quantity x plus 0.1 plus b. At this point, we can compare the equation into the general format for the method, but take note that the equation uses capital Y and capital X for the equation as they were already modified. So going back into the method of grouped averages, we divide the dataset into two groups and work on the smaller tables with x and y. This time, add columns for capital X and Y which were derived with their own respective formulas. With capital X is equal to x plus 0.1, values can be computed as 0.2, 0.3, 0.4, 0.5, and 0.6. The values of capital Y would also be computed as 0, 1.011, 1.0215, 1.035333, and 1.05225. Now take the total of capital X and Y and also solve for their averages. From here, the first equation is resolved as 0.824017 is equal to 0.4a plus b. The second group will also be computed similarly as for the former group. Solve for capital X as the following data, take their total and also their average. Capital Y is also computed with the different values of X and Y, then take the total of the values and also the average. Then, the second equation is drawn out as 1.129645 is equal to 0.9 of A plus B. Having two equations for the two unknowns, work with elimination to compute for A. Take equation 2 minus equation 1, giving 0.5a is equal to 0.305628. and dividing both sides by 0.5, A is then determined as 0.611256. Replace A with the value in equation 4, giving the formula 0.9 times A, which is 0.611256, plus B is equal to 1.129645. And the value of B is taken as 0.5795146. Now, with A and B coefficients known, plug both in equation 2 to determine C. The second equation is 0.1002 is equal to A times 0.1 squared plus B of 0.1 plus C, which then will yield C, which is equal to 0.036136 by replacing A and B. So the quadratic equation of the best fit curve is f of x is equal to 0.611256 x squared plus 0.5795146x plus 0.036136. Example 2 requires the best fit curve with the format y is equal to ax squared plus bx plus c for the following data. In this case, use a point from the set such as 1 and 1.8 and then plug them into the equation. By deducting these two equations, we are able to arrive at y minus 1.8 is equal to a times the quantity x squared minus 1 squared plus b times the quantity x minus 1. And again, expand the equation to eliminate the squares, and that is by using difference of two squares. Extract the similar term from the right side of the equation and transpose it to the left side. Thus, we arrive at the modified equation in the general form of a line, which is y minus 1.8 all over x minus 1 is equal to a times the quantity x plus 1 plus b. From here, focus on the dataset and identify the grouping of coordinates. In this case, we have 3 points in the first group and 2 points in the second group, as the dataset has odd number points. Add 2 columns for both capital X and Y with their respective formulas. Then complete a table in order to determine the total values and the averages. The first equation can then be identified as 0.766667 is equal to 1a plus b. Do the same procedure with the second group of coordinates. Complete the values for capital X and Y, and then take their total and also their average. From the averages, the second equation can then be drawn as 1.425 is equal to 4.5a plus b. The first and second equations are determined, and by subtracting equation 1 from equation 2, we would have 3.5a is equal to 0.65833. Thus, a is taken as 0.188095. By plugging this value into any of the equations, say equation 1 for this case, b is then computed as 0.578572. Now, with a and b coefficients known, plug both in equation 2 to determine c. The second equation is 1.8 is equal to a times 1 squared plus b times 1 plus c, which then will yield c is equal to 1.033333 by replacing a and b. So the quadratic equation of the best fit curve is f of x is equal to 0.188095x squared plus 0.578572x plus 1.03333.